sterilization methods in industrial biotechnology. My name is Shruti More and now let's start with our video. So first, these are the content slide. That there are some topics that we are going to see in the coming video. The first is the importance of it, the common agents that are used in chemical sterilization, ETO, which is the mostly used, and then there is formaldehyde, butyraldehyde. Then we are going to see about the applications of the sterilization method, and advantages and disadvantages. Now we will see the introduction part. Okay. So sterilization means sterilization means completely eliminating microorganisms such as bacteria, uh, and bacterial spores, viruses. It is important in biotechnology because contamination can affect products quality and production. Quality of this we can use chemicals like ethylene oxide, hydrogen peroxide, formaldehyde, butyraldehyde, parasitic acid, and also the most common one, alcohol, ethanol, 70%, which is most commonly used which is most commonly used in for killing the microorganisms. If we talk about first sterilization, sterilization is the process of completely eliminating the microorganisms. Okay, but there are four main types of methods that are being used. First is heat sterilization, second is filtration, third is radiation, and fourth one is chemical sterilization that we are going to talk about. But I will give you overall information for the other three also, that heat sterilization uses steam or dry heat or inoculating or with inoculating the flame between the flames. Uh, this is by heat, which can kill the microorganisms around 121 degrees Celsius for 15 to 20 minutes. Filtration used for heat sensitive liquid and gases, radiation used for surface and air, and then nextly is used for heat sensitive instruments. Okay, so now we will see the importance of chemical sterilization. Chemical sterilization helps prevent contamination. It maintains the quality and safety. It maintains the quality and safety of biotechnological products. It is useful for heat sensitive materials such as plastics and certain equipment. It also helps reduce production losses and maintain sterile production conditions. Next, we will see the common agents. Now, as of I have said at the start also, that alcohol is the most commonly used. Even at your home, you use Dettol, which contains alcohol that kills the microorganisms which we use to wipe the floor. But now we see ethylene. But also we will see the other ones also. The commonly used sterilizing agents include ethylene oxide, formaldehyde, and butyraldehyde, as we have talked about. Chlorine compounds and alcohols are commonly used for disinfection and surface cleaning. As I said, uh, if we talk about ethylene oxide, it is a gaseous sterilizing agent. Okay, because now we are going to talk about ethylene oxide. It is a gaseous sterilizing agent. It is mainly used for materials that cannot withstand heat or moisture. It works by damaging proteins and DNA of microorganisms. It is effective against bacteria, viruses, fungi, and bacterial spores, mainly all the microorganisms. However, it is toxic and requires careful handling and proper removal of the gas before the material is used. We can use ethylene oxide or to clean tools and laboratory instruments. But mostly many labs use alcohol because it is more safer and easier to even handle with. There are also some disadvantages and advantages for it. Like advantages, ethylene oxide is good for things that cannot get hot. But disadvantages is that it is poisonous, can catch fire, and might cause cancer. This is most common because if you're going to use chemical sterilization equipments, they are going to be poisonous, that can cause fire. And it is more common that you cannot avoid this stuff. You cannot use it without the components it has. Next is formaldehyde and granuldehyde. Okay, formaldehyde. Okay, it is used for sterilizing and disinfecting agents for fumigation. Okay, it acts by damaging proteins and cellular components. It can be used. It can be used for laboratory rooms and biosafety cabinets. Although it is effective against many microorganisms, it is toxic and requires proper ventilation. If we talk about formaldehyde more, it is like used in sterilized laboratory rooms and biosafety cabinets, where these rooms are like very safe and very packed. It's always the rooms are always packed. You cannot enter without a proper kit and without a proper sanitation. You cannot enter these rooms, and these rooms can have formaldehyde. And we have seen many labs that has this kind of chemicals. Uh, and also it works against types of microorganisms, of course. Like of course, it is also toxic. Can irritate the body. The same symptoms for the that we have got from ETO. Its use has gone down because of safety worries. Yeah, like if we see most commonly, everyone uses alcohol, ethanol. These are way more easier to handle rather than these ones. Okay. Next is glutaraldehyde. Glutaraldehyde it is used for medical and laboratory equipment that cannot tolerate heat. It works by linking proteins and DNA, which kills microorganisms. These microorganisms. It is same like uh, uh, formaldehyde only if we see. It is used for equipment such as endoscopes, surgical instruments, and laboratory devices. It's effective against bacteria, fungi, and bacterial spores. And also, uh, this also has some advantages and also disadvantages. Works on molds also, but everything is common that it can hurt our eyes, skin, and lungs. Needs it is a proper handling and good airflow. Things must be washed well after sterilization. Sterilization. Next is applications. Applications like bioreactors and fermenters need to be really clean. We have to we have to sterilize the vessels and pipes and all the other parts so that bad microbes do not get in and mess up the fermentation process. Pharmaceutical manufacturing is very sensitive. We have to make sure all the equipment and the packaging and the whole area where we make medicines and vaccines is completely sterile. Some laboratory equipment is too sensitive for heat, so we have to sterilize the glass and the plastic and the instruments and containers where we grow cultures in a way. In colleges, it is way morely used the stocks. We use autoclaves. Then there are incubators. Then there is UV rooms and stuff like that. And also we generally clean the glasswares. We autoclave them. We evaporate the air out of it to make it more cleaner. We wrap it around and make it in sterile condition to use. And after that, we also use this chemical agents. So next is the advantages. The method is good for things that get damaged by heat. It gets rid of bacteria and viruses and fungi. The method works works even when it is not very hot. It can reach all parts of the equipment and the packaging. The method helps the product good and sterile. Their limitations are some of the chemicals used are bad for people and the environment. These chemicals can leave stuff behind. You have to be careful when you use these chemicals and make sure the air is clean. The method can cost a lot of money. Some ways of doing it take a time to make things sterile and to get the air clean again. Sites that I have, which I have gathered the information, so that you can also access from these links and have more information from the sites. So to conclude with, chemical sterilization is an important method in industrial biotechnology. It provides an effective alternative when heat or radiation cannot be used. However, the choice of chemical depends on the material required, level of sterilization, and safety considerations. Proper handling and safety precautions are essential for effective chemical sterilization. Thank you.